Before we get started, please take a moment to read our disclaimer. This course is designed to give employees and employers some basic knowledge of some overhead and gantry cranes and general industry. Review this course will not deem someone a competent or qualified person or to be able to operate a crane. My name is Richard Harper, and I'm a safety consultant with Kentucky Safe. And in this webinar, I'll be giving you a general overview of overhead and gantry cranes in a general industry setting. OSHA defines a crane as a machine for lifting and lowering a load and moving it horizontally, with the hoisting mechanism an integral part of the machine. Cranes, whether fixed or mobile, are driven manually or by power. OSHA defines a hoist as an apparatus which may be a part of a crane exerting a force for lifting or lowering. What transforms a hoist into a crane is the movement of the load. Looking at both photos, starting with the left, this would be considered a crane, as the material being hoisted, or the load, can be moved vertically, but horizontally as well. The photo on the right, the hoist appears to be in a fixed position and can only move the load vertically, which would make the equipment on the right just a hoist. Next, we are going to go over some types of overhead and gantry cranes. The first type being a top running cranes. Top running cranes can be identified based on the location of the hoist and the trolley that runs on top of the bridge or bridges. On a bridge crane, the bridge or bridges run on top of the runway beams. They can be cab operated, pendant operated, or remote operated. The two examples pictured are a top running double girder bridge crane and a top running double girder gantry crane. They are typically used in industries that require cranes of high capacities, usually over 10 tons. 29 CFR 1910-179 would apply to these cranes, as ANSI ASME B30.2 1967 was adopted and incorporated by reference as 29 CFR 1910.6 E19. The next cranes we'll be talking about will be of the underhung type of crane, or as they also referred to as bottom rung or under running. Underhung cranes are identified by the hoist and trolley running underneath the bridge or bridges. Underhung cranes are configured to handle lighter capacities, usually 10 tons or less. Due to their small size and typically requiring less floor space to operate, underhung cranes have become more commonly used in a variety of industries. Unbeknownst to some employers, 1910-179 does not apply to underhung cranes. This is due to OSHA not adopting the ASME standard, the current one being B30.17, into Part 1910. The general duty clause would apply, as underhung cranes do have industry recognized hazards associated with them that, when employees are exposed, can result in serious injuries or death. The crane pictured is a underhung single girder bridge crane, which the bridge is running under the runway bridges. The next crane pictured is a top running single girder underhung hoist crane, where the bridge is running on top of the runway beam, but the hoist is running below the bridge. Again, this still being considered an underhung crane, 1910-179 would not apply and would fall under the general duty clause. The last two cranes I wanted to mention are monorail and jib cranes. A monorail crane is where the hoist runs along a stationary beam, as can be seen in the picture on the left. A jib crane consisting of a vertical member, which extends a horizontal arm that the hoist runs along, as pictured to the right. Again, 1910-179 would not apply to these types of cranes, as OSHA did not adopt ASME 30.17 that pertains to them. The general duty clause, though, would apply, which in Kentucky is KRS 338-31 or Section 5A1 of the federal regulations. With that, next we're going to start talking about crane inspections. When it comes to crane inspections, 1910-179J would apply to top running overhead cranes. For cranes that fall under ASME 30.17, employers would reference this standard first regarding inspections. Employers would then reference secondary standards such as ASME 30.16 for inspections of the hoist and ASME 30.10 for the inspection of the crane hook. Next, we will be discussing the types of crane inspections, starting with frequent inspections. Frequent inspections are done on a daily to monthly basis. For cranes that fall under 1910-179, paragraph J2 would apply. For cranes that do not fall under 1910-179, you would reference ASME 30 B30.17, ASME B30.16, and ASME 30.10. Next, we're going to go over some basic items that are inspected during frequent inspections. Some of these items include all functional operating mechanisms such as remotes, pendants, cabinet controls, to ensure they are in good working order, to ensure that the controls are properly labeled. If a hoist uses a chain, inspectors will inspect it for excess wear, such as bent or twisted links, stretched links, gouges. If the hoist uses a rope, the inspector will need to inspect it for items such as a reduction of diameter, broken wires, corrosion, kinking, etc. In regards to the diameter reduction, maximum reductions are given in ASME 30.2 1967 for cranes covered in 1910-179 based on their rope size. That being said, I recommend employers to use the no more than 5% of the nominal diameter that is used in Part 1926 for construction. That is actually derived from a newer edition of ASME 30.2. It is also included in ASME 30.16 and thereby is to be followed for cranes that are typically not covered under 1910-179. This measurement is typically taken using a machinist caliber or a micrometer and is measured from the highest points or crowns of on both sides of the rope. In regards to broken wires, ASME 30.2 1967 that pertains to cranes covered under 1910-179 states that 12 randomly distributed wires and one rope lay, which is when the rope strands make one complete rotation, or 4 broken wires in one strand in one rope blade constitutes a removal from service. Again, I recommend employers utilize the more stringent uh, 6 randomly distributed wires in one rope lay, or 3 broken wires in one strand in one rope lay. That is used in Part 1926 for construction, and again is required for cranes not covered in 1910-179 as it is included in ASME B 30.16. Inspectors would also inspect the crane hook for deformation or cracks. For cranes that fall under 1910-179, any hook having a throat opening greater than 15% or a 10% twist needs to be removed from service. ASME 30.10 recommends any hook having a throat opening greater than 5% needs to be removed from service. It is also recommended that if the hook has a safety latch, for it to be in good working order and not damaged. The next type of crane inspection is a periodic inspection. This inspection is typically completed at least annually and is a more thorough inspection of the crane. In addition to inspecting all items included in the frequent inspection, the inspector would inspect some of the following items: deformed, cracked, or corroded members, loose bolts or rivets, cracked or worn sheaves or drums, worn, cracked, or distorted parts such as pins, bearings, shafts, gears, rollers, locking, or clamping devices. In terms of documentation, 1910-179 requires that the inspection of the hooks, the hoist chain, and hoist rope be documented at a minimum during a frequent inspection, and that the document include the date of the inspection, information that identifies the item, such as the serial number, and the signature of the inspector. According to ASME 30.17, 30.16, and 30.10, records are not required for frequent inspections. That being said, I always encourage employers to document the frequent inspection to assist in maintenance tracking and to prove that an inspection has been conducted of the crane. Both 1910-179 and ASME require that records be kept for periodic inspections. When it comes to training, 1910-179 doesn't give any specifics. 1910-179B8 requires only individuals designated by the employer to operate cranes. 1910-179A35 defines designated as being selected or assigned by the employer or the employer's representative as being qualified to perform specific duties. In a letter of interpretation for 1910-179A35, OSHA indicated that it would interpret an individual as being qualified per the operator qualification provisions within ANSI ASME B30.2 1967 that is incorporated by reference. Qualification provisions in ANSI ASME 30.2 1967 vary based on the type of crane. For example, ANSI ASME 30.2 1967 requires operators of pendant operated cranes be given and pass a practical operating examination. OSHA also recommends using paragraph L in 1910 178 pertaining to powered industrial trucks as a guideline for developing a training program. When it comes to cranes that will fall under ASME B30.17, the requirements are more stringent and are very similar to the requirements of a powered industrial truck program. The employer is required to implement a training program that includes some of the following: physical characteristics of the workplace, performance characteristics and complexity of the equipment, types of load to be handled by the crane, responsibility of a crane operators as they pertain to some of the following regarding inspections if they are the ones that conduct them, rigging of the load to the crane, and performing lifts with the crane. A written and practical examination is required, and there needs to be some formal record of training. And with that, this concludes our webinar pertaining to cranes in general industry. For more free online learning opportunities, please visit our website. And thank you for watching this presentation.